Supplemental math videos from Circle Christian School. Okay, why do all this trig stuff? Well, techniques in trigonometry are actually quite relevant for things in navigation, satellite systems, astronomy, naval, aviation, land surveying, things of maps. But we're going to investigate as we kind of go through these next 3 lessons here. Different things as to why the trig. And it may not be that you're going to go into this type of career. Sometimes it's just a matter of practicing what happens in the real number system. How do we solve basic equations anyway? The challenge of solving basic equations. That math is somewhat important, whether you're going to be some great math whiz or if you're just going to do your checkbook. All of it is a mathematical challenge. First thing we're going to do is just kind of work on the trig functions. There are, of course, 2 ways for doing this. The first way is working with the right triangle, and then there's kind of the way of working with the trig itself and some trig identities. This particular example just pretty much works with the right triangle trig as opposed to using a little bit of the trig identities. So the first thing we're going to have to do is take our information here and figure out pretty much where our triangle is hanging out at, because that helps a little bit with the positive and the negative signs. That's the whole thing. Is it positive or is it negative? Because if you have a negative and a negative, it's going to make a positive. So it makes it a little bit obscure as to whether your function is positive or negative. So we have a secant theta at negative 1715, which secant goes with cosine. So we know we're working with some negative cosine stuff. And we have a sine that's positive, 8 and 17. And we know these are here. And we have to find the ones where it both qualifies for. So we know that's pretty much where our triangle's hanging out at. It's going to be like so. Okay. Now what we're going to do is find the 6 trig functions. We are blessed with the fact that we have our sine one, which is going to be 8 over 17, which makes the cosecant just as easy at 17 over 8. The secant is a negative 17 over 15, which is going to make our cosine be a negative 15 over 17. And by this time you're going, whoa, wait, where did the 15 come from? Well, I just used the Pythagorean theorem that 8 squared plus b squared here has to equal my 17 squared, which turns out to be 225 or 15. And because we're sitting over in the second quadrant, we know that whatever is happening with the number down here has the negative values. So here's our negative 15. And then we have tangent, which is going to be O over A. So O over A is going to be the 8 over the negative 15. And then cotangent, going to flip me around. We get a negative 15 over the 8. Perfect. Now working on a little bit of simplifying here really requires having that one page always kind of next and close to you. Nobody here is looking for a bunch of real memorization of everything that happens along this page, but just being able to kind of connect it together with different things. You're always going to be looking for, hey, this equals something, and looking for some sort of kind of common terms inside here, you know, so that everything's a sine or everything's a cosine or everything's a cosecant kind of thing. So you got to kind of pick which sign that you really want and kind of work toward that using one of those little identities. So what we have is sine theta being multiplied to cosecant theta minus sine theta. And I'm just going to use a little bit of the distributive property there to bring the guys together. And it's just a matter of playing with it. One way is just going to be a little bit better than another. There is no real set thing. You just got to kind of go, am I going to multiply here? Am I going to factor things out? To go and play with it to get where I'm going to some sort of little identity. It's just, I hate to say it, it's just a matter of playing with it. So what I did is distributed. And we know that when we get a cosecant here, I go, oh, look, it's kind of like, it's one of those identities. And that's going to allow us to do a little bit of canceling out, which gives us the 1 here. And then we've got the sine. And taking a look at another little identity here, you go, oh, 1 minus sine squared by manipulating a little bit of the equations here with the Pythagorean identities, you'll find that it is the same as cosine squared theta. Yay! Now this particular equation lends us up to going, okay, I guess I'm going to have to do a little bit of factoring as opposed to a little bit of simplifying. And careful look goes, well, let's see, I got a perfect square, another perfect square here, minus sign in between. Let's check out the difference of 2 squares. It happens a lot. Either it's going to look kind of quadratic or it's going to look like one of the special quadratics. So I'm going to work this out to being a difference of 2 squares here. So we're going to have sine squared x for both of these, sine squared x. It's kind of fun that I change up my s's here. I really don't know why I do that. Plus cosine squared x, and then minus cosine squared x. And going back to our handy dandy sheet here, we realize that this cute little guy here actually equals a 1. So that leaves us with the sine squared x minus the cosine squared x, which is, of course, our final answer. Here we go. Now, here's your 50 plus 50 star point activity here. Find one good reason. Oops, I forgot the reason. One good, we'll put it inside here. Here you go. Nice little discovery there that I had messed up and forgot reason. Find one good reason for using trig. Here you go. Write it on your paper. Nice big discovery here. Here you go. That right there, whatever is inside, this little guy right here is going to be worth 50 points. Okay guys, have an awesome day.